day, everyone, or welcome to a new subtopic in Indices and Logarithm SSCE syllabus. We are treating indices in algebraic terms and algebraic powers. Let's take our first example. Simplify cube root of 27a raised to power minus 6. The options are given: a 3a, b 3a squared, c 3a raised to power minus 2, d 9a raised to power minus 2, e 9a squared. Solution. When you look at the problem, cube root, automatically will give you the secret of what to do. Everything inside under the root can be expressed in 3 and power of 3. We express 27 in 3 and its powers. So we can conveniently say cube root of 27a raised to power minus 6 is equals to 27 is 3 raised to power 3, and we still leave our a raised to power minus 6. Then we close our bracket. We have introduced bracket now. Raised to power 1 over 3, which is the cube root. Now remember, in indices, with this we can bring in the powers to work with the ones, the power 1 over 3 that is outside, multiply it with the ones inside. And that will now give us 3 raised to power 3 over 3, and a raised to power minus 6 over 3. And 3 raised to power 3 over 3 will give us 3 raised to power 1. We do not show the 1 there, so we just write 3 down. But when you look at the other, a raised to power minus 6 over 3 will become a raised to power minus 2. And that is our solution. Let's take another example. Simplify cube root of 27 s cubed y raised to power 9. The options are given: a 9xy cubed, b 3xy raised to power 6, c 3xy raised to power 3, d 9y raised to power 3. Now solution: cube root of 27x raised to power 3 y raised to power 9. That should tell you that work on the values inside as much as you can to power of 3. I will introduce a bracket, and 27 becomes 3 raised to power 3. S is already in power raised to power 3. 9 is already in, you can work with power 3. So we'll close our bracket and write it as raised to power 1 over 3. It's the same thing. We are only representing it properly. Then applying the rule of indices, your power raised to power 1 over 3 can now multiply the powers inside the bracket. And we have 3 raised to power 3 over 3, then x raised to power 3 over 3, then y raised to power 9 over 3. Simple arithmetic, 3 raised to power 3 over 3 will become 1. So we just leave it like that. We don't show the 1. And x raised to power 3 over 3 will become 1. We just leave it like that. Then y raised to power 9 over 3. 9 divided by 3 will give you 3. So y raised to power 3. And that will give us our answer. Another example. Simplify square root of 8 raised to power 2 times 4 raised to power n plus 1. Then you go to the denominator now. 2 raised to power 2n times 16. The options are given: a 16, b 8, c 4, d 1. Solution. Let us represent our given problem properly. We rewrite the given problem. We say it's equals to, produce a bracket, 8 squared times 4 raised to power n plus 1, close your bracket, that's the numerator, over 2 raised to power 2n times 16. Then we'll close our bracket, raised to power half. We have not done anything, we only represented our problem properly. Our target will be to make each item that cannot cancel out in powers of 2, since we are dealing with square root here. And that will become equals to 8 squared times 4n times 4 raised to power 1. In indices, 4 raised to power n plus 1 is the same thing as 4n times 4 raised to power n times 4 raised to power 1. Then in the denominator we now have 2 raised to power 2n times 16 is 4 squared. Close our bracket and raise it to power half as it ought to be. And that will give us equals to 8 squared times 2 raised to power 2n. We are seeking to raise everything inside the bracket to power 2 times 2 raised to power 2. Then the denominator still remains 2 raised to power 2n times 4 raised to power 2. Then we close our bracket, raise it to power half. 2n will cancel out. 2 raised to power 2n will cancel out for the denominator and numerator. While power half, raised to power half, will cancel out all powers of 2. And that will now give us equals to 8 times 2 all over 4, which is equals to 4. Let's take another example. Simplify 27x cubed times 64x raised to power 6, bracket close, raised to power 1 over 3, times, bracket open, 3x, bracket close, raised to power minus 1. The options are given. A, 3x, B, 4x, C, 4x squared, D, 4x cubed, E, 12x cubed. Solution. We try to arrange our problem, our given problem, to reflect the power of 1 over 3 outside. That will imply that our given problem, which is 27x cubed times 64x raised to power 6, bracket open and close, raised to power 1 over 3 times, bracket open 3x, then bracket close, raised to power minus 1 will be equals to, bracket open at the numerator, 27x raised to power 3 times 64x raised to power 6, bracket close, raised to power 1 over 3. Then our 3x, which is raised to power minus 1, will now be 3x at the denominator. Next, we seek to raise items under power raised to power 1 over 3 to power of 3. And that will be equals to 3, bracket open, 27 will now be 3 cubed, and our x cubed, which times 64 is 4 cubed, times our x raised to power 6 that is there. Then you close your bracket at the numerator, raised to power 1 over 3. Of course, our denominator still remains 3x. And that value will now be equals to, when you look at what will happen there, the power of raised to power 1 over 3 applied to all the powers in the bracket. You have 3 raised to power cube will become 3. X raised to power cube will become x, times 4 raised to power cube will become 4. Then x raised to power 6 divided by 3 will become x raised to power 2. Of course, your denominator still remains 3x. And that will be equals to 4x squared. Let's take another example. Simplify 3 raised to power x minus 1 times 3 raised to power x minus 1 times 9 raised to power x plus 1 times 27 raised to power x, that is 27 raised to power minus x. All over, then we'll go to the denominator, 81 raised to power 5x minus 3. Solution. The lowest base here is 3. We can change 9, 27, and 81 to 3 and its powers. We write our problem, which is 3 raised to power x minus 1 times 9 raised to power x plus 1 times 27 raised to power minus x all over 81 raised to power 5x minus 3 equals to 3 raised to power x minus 1 times, note 9 becomes 3 squared. That is carrying power. So we introduce bracket to protect the former power that was there, which is x raised to power. That is power x plus 1 times 27 become 3 raised to power 3. We introduce bracket as well, raised to power minus x. Over our denominator will become 81 is the same thing as 3 raised to power 4. But remember there was power there, so we introduce bracket to protect the former power that was there, which is 5x minus 3. I'll close the bracket. Then, to open up the powers in the bracket, we now start working. equals to 3 raised to power x minus 1 times 3 raised to power. Once you open up the power in the second 3 there, 2 will now multiply x and it will become 2x plus 2 times 1 become 2. That's why you now have 2x plus 2. The 3 in the power there times the minus x outside will become 3 raised to power minus 3x. In our denominator, we have 3 raised to power 20x minus 12. What happened was that 4 multiply the bracket, 5x, 4 times 5x become 20x, then 4 times minus 3 become 12, minus 12. Applying the law of indices to the powers at the numerator, you will now have, since they are all the same powers of 3, we now have 3 raised to power x minus 1 plus 2x plus 2, close your bracket, plus, introduce bracket to protect the minus, minus 3x, then you close your bracket, over 3 raised to power 20x minus 12. Now, let's still look at the numerator and see how we open up the bracket, which is equals to 3 raised to power x minus 1 plus 2x plus 2 minus 3x, all over 3 raised to power 20x minus 12. And that will be equals to 3x. If you take like terms together, then you now have minus 3x and plus 3x. So those ones will go. In minus 1 plus 2 will become just 1. So we now have our result as 3 raised to power 1 over our 3 raised to power 20x minus 12. Now, bringing the denominator upward, we now have equals to 3 raised to power 1 times 3 raised to power minus. Then we introduce a bracket to protect what we brought up, 20x minus 12. Then you close your bracket. And that will still give us the value of equals to 3 raised to power 1 times 3 raised to power minus 20x. And minus times minus become plus in front of 12. So it becomes plus 12. Now we go further. That will be 3 raised to power 1 plus 12. That of minus, we take it down to work freely with. And that will be 3 raised to power 20x. That will be equals to 3 raised to power 13 over 3 raised to power 20x. Yes, this is the last example for this subtopic. Next, we have exercises from our hidden fact in new SSCE mathematics, page 77. Try your hands on these exercises. The answers are provided at the end of the book, either the soft copy or the hard copy. Thank you.